Alrighty, so let's get started. Let's get this show on the road. Welcome to another OpenChain webinar. This is part of our ongoing series. This is actually webinar 100, so it's a nice little milestone for us. As usual, we're covering a topic that will be of interest to people dealing with open source in supply chains. Today, we're going to be looking at a topic very much on people's radar. So LLM-generated code. This is something that has come up in meetings and events over the last year. We had a presentation from Fujitsu, for example, about 6 months ago, just talking about what they are doing regarding LLM-generated code and how they're thinking about it. Now we're going to get a bit more holistic and get a big picture overview based on research on the topic. Before we get started, though, our usual thing, the antitrust policy notice. The full Linux Foundation antitrust policy can be found on our website. And if you're from a member company, you can ask questions of our counsel, Andy Updegrove. Now, with that out of the way, let's have a look at who's going to talk to us today. So we're going to have Oscar talking. And we have an interesting creature on the line. Oscar is a genuine professor and researcher chap who is here to lend us some solid analysis about similarity detection in large language models. This is tied into the ScanOSS platform. It was conducted using their open source based platform, and it will give us some insight into what concerns we should or should not have regarding LLM generated code and open source compliance. Well, I guess the best thing to do is simply to hand over to the expert and let him take the stage. Oscar, the floor is yours.
Okay, thank you, Shane. Let me briefly share my screen and let's start with this. Well, first of all, thank you everyone for being here. I'd like to begin by introducing this research, which aims to shed light on risk associated with the use of AI-generated content, specifically from the perspective of the open source. Jane did it, but let me briefly introduce myself. I'm Oscar Goñi. I'm a researcher and professor. Although many know me as Kiki, I'm member of the Software Transparency Foundation. I hold a degree of system engineer and a PhD on computer science. I've been in the academia for 20 years, and in the software industry for 25 years. So just quickly jump to our topic of the day. And I would like to talk to you and think, what do we think that why this research is relevant? So how often do we hear a new release song that feels familiar, only to quickly dismiss the thought that believing is to be entirely original? So in trust, we may not be far off. While I'm not a musicologist, it's completely possible that the composer drew significant inspiration from this previous work. In some cases, this similarity is so striking that it leads to legal action or over copyright infringement. But a comparable dynamic has long existed in the software industry. A reality that many of you are already aware of. But what's changing now is the scale and the complexity of this issue, particularly with the rapid adoption of AI-generated code powered by the LLMs. These LLMs are typically trained on public available code bases. Ideally, it is open source. If they had been trained with proprietary or commercial code, the legal and ethical concerns would already be more acute. But even with the open source ecosystem, the situation is far from straightforward. So let's consider a realistic scenario. A developer writes a prompt to solve a specific technical challenge and use LLM to generate the source code. In the best case scenario, the code has no similarities with the code used to train the model. So the developer does not have to worry about copyright statement, authorships, or even software license requirements. But if the code has strong similarities with existing code, the copyright infringement risk may be a concern, and the consequence, license requirements, for instance. There is where the ghost of plagiarism begins to emerge. You may choose believe it or not. You may find it alarming or not. So let me briefly walk through the story. Back in 2023, the rise of AI Gen began to reshape the software industry. That let us solve programming problems very easy. Even for those with no prior coding experience. It was amazing. So naturally, the industry started raising concerns. To what extent the AI-generated code is replicating source code, even partially or fully? So let me briefly describe how we handle this kind of concerns as Software Transparency Foundation. All the research projects within the Software Transparency Foundation always begin based on commercial or intents or concerns. That is, companies pose the problems and the foundations allocate resources to address it. The results are then made public available. In this particular case, Scano SS, a strategic member of the Software Transparency Foundation, bring us this concern and trust us a clear and urgent mission. So is the STF technology able to detect similarities to the point that potentially could be perceived as a plagiarism? Or if the answer is yes, how much of the code generated by AI overlaps the open source code? And with that, we have a broader set of questions. So, for example, what happens when the code is not just similar enough, but verbatim copy? What are the implications for the rest of the code base and the company shipping it? So, after an extensive discussion, we reached a shared conclusion. We agree that detecting the similarity in the source code is just the first step to understand the true scale of the problem we are generating. It is not about identifying reused fragments of code. It is about measuring exposure, quantifying risks, and laying foundation for responsible AI code generation. So in this scenario, STF is in a unique position to work on this topic, given that all the software we have is open source, and also the foundation has a program that enables the osskb.org service for research projects. So that is the moment when my journey begins. I crafted a simple prompt asking a large language model to generate source code to solve a specific, well-defined problem. I had to admit, it was until the fourth attempt that I found what I was looking for. It felt like hearing a familiar melody. It's having our own voice, our own rhythm. You can see here that what found is a near verbatim copy of the ScanOSS winnowing algorithm. Even the inline comments had been preserved almost exactly. It wasn't just code generation, it was code recollection. This moment marked a turning point. If such a close match can emerge from a basic prompt, then how often might this happen across millions of AI-assisted development workflows? And more importantly, are we prepared to detect and respond to it? So in 2024, a study revealed that after training a large language model on a substantial dataset, about 800 gigabytes of source code, the model produced upon request for a specific implementation a non-negligible amount of code that appeared to match segments from the training data. The overlap ranged between the 3 and 5%. So this led us a question. If OSSKB is several larger than the training dataset used in that study, what percentage of AI-generated code should show similarity when compared against a broader universe of open source, or at very least a close approximation? So let me show you briefly our experiment. We then decide to launch a large-scale investigation with clear objectives. It's just to reproduce the result of the previous study, and additionally, to verify whether the similarity persists or increased when this comparison is performed over a similarity larger set of source code. As a second goal, we aim to assess whether the winnowing algorithm used in the STF, in the OSSKB technology was well suited to use this case, or at least serve as a starting point for other methods. Well, our initial assumption was that between 3 and 5%, the original result of this investigation will represent the lower bound, the baseline. But we also knew that LLM-generated code through statistical synthesis or even coincidence could in practice exceed that threshold. And what that means? It means that a developer could assume that the generated code falls within the 5% range of inspiration, while in fact it may reproduce large segments of existing code with all the associated legal and compliance implications. So, but unfortunately, we were not able to access the original prompts to generate the code in the study. What we did get is just the output of those prompts. It's about 10,000 snippet codes, just the outputs. So let me briefly show you the setup in our experiment. In short, all the technology is open source, is fully open source. The data service used is osskb.org from the Software Transparency Foundation. You can access it through an open API. So I placed all the links at the end of the presentation. Okay, let me talk briefly about the service. The service provides commercial grade detection capabilities, again, 300 millions of open source projects, and includes snippet matching features that compares any piece of OSS, any piece of code against open source codes. Additionally, the osskb.org service enriches the detected software with useful information, focus on the license compliance use case. The OSSKB.org service is powered by the OSSKB knowledge base. This knowledge base is maintained by ScanOSS. Well, and in this experiment, we use that snippet information to detect traces of code reproduction. Next, for the from the different set of tools, the different software composition analysis tools that integrate with the OSSKB.org service, we have choose ScanOSpy tool. It's a command line utility that fingerprints the code to be analyzed and send it to the OSSKB.org service. And finally, I developed a small Golang script to post-process the scan results, apply the filtering, and present the final results. So, as I said before, the service is using the winnowing based is using the winnowing algorithm. Let me show you quickly how it works. Well, the messaging logic is based on the well-known winnowing algorithms. This algorithm is generally used for similarity detection in documents. ScanOSS has made slight modifications to adapt it for source code detection. Well, the algorithm works as follows. Given a text, after a simple modification, simple normalization that only keeps alphanumeric characters, the algorithm computes a hash over a sliding window of fixed size. What does it mean? So that it starts, creating the hashes, and then as this window moves across the code, it continuously generates hashes for each segment. From this, a subset of fingerprints is selected based on specific selection strategy, in typically choosing the minimum hash value within the window of hashes. This approach ensures that minor changes in the code do not significantly affect the fingerprint, while preserving the ability to detect substantial overlaps. In essence, it allows us to distill a large body of code into a consistent set of representative signatures, as a robust foundation for identifying similar reused code. So just a detail of implementation for this case. Due to the data is stored and at scale, ScanOSS implementation of the winnowing algorithms takes an additional step that is rehash the fingerprint. This is just to achieve a more uniform distribution of the fingerprints, which improve the performance and accuracy when indexing. But once again, the algorithm is fully open source, and if you are interested in the details from its internal design to the rationale behind the configuration we use today, you'll find all the relevant information and analysis in the link provided at the end. So basically, in short, the initial similarity search is limited to finding consecutive matches among these hashes. Okay, so we ran the test. It took about 3 minutes. But at first, the results were not particularly encouraging. Although we identify approximately 3,000, more than 3,000 files with matches to known source code, many of them show a quite low similarity percentage, about between 2 and 5% range. Furthermore, we had to account for positive where the fingerprint matches, with the fingerprint have the match, but the file, the matches file, had no meaningful semantic or structural connection to the source code. So those kind of files should be removed. In this situation, I'm showing you one case where this is should be removed, and this is a false positive. So the fingerprint comparison seems to be similar, but the source code is not. There's nothing to see one with the other. So to address this, we define a dedicated filtering and evaluation phase. In order to perform meaningful comparison, we first need to collect the set of potential inspiration files. The original source we suspect the generated snippet might have been based on. This will serve as a baseline for a deeper analysis. So we then establish multiple similarity thresholds and define 4 key metrics to quantify the overlaps. Some of them were used in the previous work. The Jaggard distance, the shard singles, the value-4 score, and the winning match ratio. I will not dig in detail for all the metrics, but the Jaggard distance, this Jaggard distance is a metric. It's a distance. It's not matching the exact text, but it's just measures how much it seems one word with the other one. So in this case, the shard singles are the core component of the Jaggard distance, while value-4 provides a direct comparison at text level. However, since this metric typically compares a code snippet against the entire source code, they often dilute the significance of localized matches. What I mean is just we are not comparing just a snippet. We are comparing the whole file, the whole inspiration file where it was extracted. The snippet was extracted. So in order to address this, I introduced a new metric. I will show you the details after this about the winnowing matching ratio, which allows us to better evaluate the reference of those matches by considering the portions of line matches by the winnowing algorithm. This enables us to calculate a more focused similarity code centered exclusively around the matching ratio detected by the winnowing algorithm. This is about the winnowing matching ratio and how it behaves. You can see here we have the complete file, and we can have here the matches ratio. This is the real similarity that we are having on against the match, the OSS source code and the matched file. So you can see that not the whole file has matched with the AI generated snippet. So we have to consider into account the amount of fingerprints that have been created for this snippet and the amount of fingerprints that have been, the amount of snippet has been matched, the amount of fingerprint that has been matched. So the winnowing matching ratio consider the amount of fingerprint that have been matched and not the distance between one word and another word. So you can see here the numbers about defining several thresholds when dealing with similarity of the source code. We can see here that the winnowing algorithms have a good behavior. So finally, to wrap up this and the number, we can see a slightly higher percentage than the one reported on the original study. In fact, the authors reached out, pointed out that such an increase is expected when compared against a significantly larger dataset of source code. Furthermore, it can be observed that our introduced metric, the winnowing matching ratio, is aiming to filtering out non-relevant source code, but it also can provide us a clear estimation of degree of similarity present in the analyzed code. In the case of this metric, and unlike the other evaluated metrics, the matches are exact, rather than to be distance basis like Jaggard distance. Therefore, it is not necessary to prove that the similarity exists. So it's not necessary to access the original open source code in order to assess potential similarity. The match is a match. So with all these results, we can confirm that those similarities are real. So why? It's just a matter of coincidence, it's just chance, or it's simply a reflection that LLM-generated code may already exist in public open source repository. I think that the origin of this overlap is completely relevant for you. The melody sounds similar. Whether it's due to memorization, conversions, or inspiration, the generated code shows a high degree of similarity to an existing source code that has potentially his own copyright and his own license. So I would like to know your feedback at the end of the presentation about, well, with this result, after 2 researchers using different methods, knowledge bases, and tools, but reaching to similar conclusions, do we require additional research to confirm that the risk of plagiarism exists? Is that risk small enough to ignore it when using AI code assistants? Occasionally, for example, using what's happened when it's used by a single developer, or it's used regularly by many developers, or other circumstances, for example, commercial use or at home, at hobbies level. So another thing is, how do we deal with this risk without snippet matching capabilities? So can we leave it with the popularity of AI code assistant? Can anyone claim that the SBOOM are complete without considering the risk of plagiarism? So if we can consider that we can say that the plagiarism exists and it is considered a risk, is this risk relevant to the benefits that this code AI, the agent bring to manufacture to their own supply chains? What are the most relevant derived risks from the plagiarism? And which are the other derived risks from the plagiarism? Well, just to close this presentation, I would like to share the steps I'm considering to follow in this direction. So based on the conclusion of this work, I'm convinced that we must continue improving on the accuracy in the search for similar code. Just to name one approach, we aim to explore comparison based on the syntactic structure of the source code, an approach that would be resilient to variable and function renaming or even changing the programming language. So, I mean, the same melody played by a different instrument. And additionally, I would like to repeat the test while considering the reasoning capabilities of the LLM. I would like to see what's happened with the similarity values, with these values, when we request changes to the AI Gen assistant. So that's pretty much what I would like to share with you. If you have any questions, I'm open to it.
Wonderful. Thank you very much indeed. And we do have a question to start. Florian asked regarding a technical part of the work, would renaming objects change nearly all the hashes? And shouldn't the normalization process also rename variables to standardized names? So a technical question about how this was done. And Florian, if you want to dig into it, you're very welcome to unmute yourself as well.
Yes, thank you very much. So the main idea was the standardization of variable names, as was said. So did you already include that in your research, or how can I imagine that?
No, we are. Those are our next steps. We are working with that, and the initial results are very promising. Yeah, but the winnowing algorithm normalization we have, well, as Cano says, have applied is a very simple normalization. It is resilient to some changes on the code structure because, for example, it's removing control characters or spaces and another minor modifications, but not completely resilient to the variable or function names or method names renaming. But we are working on this direction, and the result we are having are very promising.
If I'm allowed to add something to it,
Yeah.
The nature of the winnowing algorithm that selects the smaller hash in a window makes it somewhat resilient to change. I mean, it will be very likely that if you change variable names, the hashes will be the same. So the WFP, the winnowing IDs will be the same. But of course, at some point, if you start changing a lot, or if you completely replace all variable names, then chances are that the hashes will be different and will not match. But it's not that it's completely vulnerable to variable and function and class name change.
Mm-hmm. So from just building up a database, I mean, the problem is to calculate the hashes to build up this database. If you change the underlying logic, like variable renaming, if you change anything in the normalization, the whole database basically will be invalid because it is based on the normalization function. So I can imagine, I mean, building up a database as you shown in the initial slides you presented is already tricky. But then if you need to be very sure about the normalization already when building this database, because otherwise you scan those millions of dependencies and files, then you need to understand that the normalization changes, and then you basically need to rebuild the whole database. Or
yeah, to some extent, Florian, because actually we have done this several times, and we have experienced with different changes in normalization and changes in algorithms. We play with this all the time, and the way that we have the data structure allows us to regenerate the snippet table within a day with commodity hardware. So it's not that we need to re-download and redo everything. It's just recalculating the hashes from the source code archive.
Thank you.
No problem.
Right. We have some more questions and points in. Okay. I'll pick them up in reverse order. Atia had 3 points. One was raising that plagiarism is not the same as copyright violation, though there may be an overlap. Another was conscious violation versus accidental plagiarism. The question is, does similarity matter by itself without actual intent to copy? And then finally, actual legal violation versus perceived risk in the current, not entirely clear legal situation. So, Mattia, I think to summarize it, there's a lot left to be settled in terms of where the lines are. Would that be a fair comment?
Yeah, I think so. So, so the first thing is, we are talking about plagiarism here. At least that's the verb. That's the term that was used. And plagiarism itself I don't think, is in any copyright law actually written in. It's usually more of a moral thing, and in academia, less than an actual legal risk. There is some overlap, of course, between an actual copyright violation. So the question is, what are we trying to protect here? Are we trying to avoid legal risk, or are we trying to avoid, an moral or PR risk, which, both are valid risk we want to avoid. And this again goes in line with what is plagiarism versus copyright violation. And we come to the point that while in some courts have in the past, especially when it comes to music, been very, very trigger happy when it comes to, these 3 chords are completely stolen. This is, the changes the whole song. This is clearly stolen from somebody else. That is arguably not entirely. I don't know. I don't know how to exactly form that, but it is true that there's that in some jurisdictions, especially when it comes to music, there has been the courts have been very trigger happy, but it's harder to prove. Like the theory with music often is that you would need to prove that you didn't hear the song on the radio, which if it is a super popular song, song on the radio to have to be inspired and, are subconsciously copying it. But if we're using now an AI tool to copy code, or to generate code, that is a good question. How can you, how much exposure to the underlying code that was, potentially lifted or generated to look similar was the developer actually exposed to? So there is, just the conscious component of copying, either intent or just lack of awareness is a good question here when it comes to the actual legal situation. And then this again, goes into the,
Mattia,
is something like that actually a violation, or is it just risk management from the point of view, if can we get sued even if, the lawsuit might go in our favor? And I think that's a very fair risk to take into consideration. But yeah.
I have a question for you, Mattia, if you allow me.
Oh yeah,
You
absolutely.
one of the examples. I mean, it's okay if there is intent or no intent. That might, can you prove that the developer hasn't seen the code origin? But in the example that Kike displayed in one of the slides, there is a carbon. I mean, there is a verbatim copy of code, including the developer comments. I mean, what?
Oh yeah, no, I mean, if the developer comments, that is a good question. I mean, if at that point you don't figure it out, then that's
because
you're clearly too lazy. I agree, but
exactly.
just saying
At that
it's
point,
nuanced. Yeah. At that point,
that's the intent matter at that point, right?
Yeah, no. I mean, at that point, it may not be directly intent, but it's least you are. How do you call that? It's not callous. Shane, help me out. You're good with English.
We could go with you're a malicious actor. You're doing something here purposefully, knowing
There's,
that.
yeah, no way. I mean, not necessarily purposely, but you're being. I mean, not lazy. There's a legal term for this. Damn it, I know it in Slovenian. There's the various
Right. Maybe
states
we
of
could
intent,
phrase
like
it in
intent
English,
and
lacking the
yeah.
without due care or careless
Yeah,
act.
let's go with that. Yeah, let's go with that. Without due care. So that I would definitely say that, like Julian said, like if there's if there's developer comments in there, this a reasonable developer would need, when they see that, they would need to go, this came from somewhere.
Mm-hmm.
I would agree with that. Yeah.
I see Augustine has his hand up.
Yes. So can you hear me?
There's a lot of echo. So I saw a written comment from Augustine that the term of plagiarism was used because violation means different things in different countries.
Can you hear me now?
Oh yes, much better.
Thank you. So before, when AI started, we couldn't demonstrate that it was copying code at scale. There are two research now. Let's assume that there will be six. At some point, there will be six saying that it copies code, right? And then the question is, if you know it is copying code, you cannot claim that you don't have any intent, right? At some point, this intent thing has to go away, and you have to actually deal with the risk instead of what is happening now, which is we are ignoring the risk because guess what? Nobody can demonstrate anything. So imagine that you are using an electric guitar that knows that it's copying songs, right? And if you use it and you know that there is a 2 or 3 or 4% of cases in which it's actually copying songs, at some point you have to deal with that. You cannot claim anymore that if you're choosing this instrument compared to other, you do not want to face the risks. So it's not just ethical. At some point, I guess that if the research goes into this direction at even bigger scale, and unless the AI completely changes, the question is, should we assume that AI code assistants are copying code? Because 3 or 4%, if you have several hundred developers using AI code assistants every single day, and you are shipping several gigabytes of code, you need to assume that you will have their code that is similar, and here we deal with the definition of similar, and by similar it could be carbon copy, verbatim copy, right? And we should not let the authors of that code, I mean the open source communities in general, should not let these guys ignore the risk, in my opinion. Right? That's where we are heading. We might not be there, but I think it looks like where we are going, and it's just an informed opinion.
I'm not disagreeing with you, and I'm definitely not disagreeing with the research in general. I think it's a really, really good idea. I was just trying to put it into the legal context of risk management. That was all. And just to, as an illustration of my point of intent, is, for example, like what I usually tell our developers is like, let's say you ask the AI to generate Mickey Mouse. Clearly you had intention to violate somebody's copyright. Like, okay, you say, okay, create a cartoon mouse that has, an oversized hands, oversized feet, wears a specific pair of trousers and large shoes, and has white gloves. Yeah, that Mickey Mouse pops up, and you're like, yeah, probably your fault again. Then what happens if you say, I just want a cartoon mouse? The thing coughs up Mickey Mouse. Maybe not intent, but it's Mickey Mouse. You should have noticed it's Mickey Mouse. But so this is what I mean. Is like, we are at this point, like, the machine itself is not cognizant, whatever some people say. But in this case, like, we're far from that, if ever. So at the end, it's still the developer, the human being operating it, and there's where the thinking happens. And I agree with the research, and I also think it's really useful, because I think, like, a big risk of these LLMs is also that we're trying to offload the thinking, and therefore the developers, or anybody using them, is trying to think less and therefore not learning, which is a different can of worms. So yeah, so I just wanted to put this into perspective. And again, I have nothing against the idea in general, just trying, wanted to add to the discussion, that is all. But I see Marcel has a good suggestion we should discuss.
Marcel, you had a note. What about proper attribution of copyright holders and proper licensing once that it is known that it is similar code? So if you see that it's similar code, to start attributing the copyright holders. Julian did reply in the chat that he thinks that's a good start. But if that is or not would depend on the license under which the original code was published. Julian, is that a reference to, what if it was, for example, GPL code?
Exactly. Then it just goes beyond just attribution, but also it affects the license under which your final or derivative work will be released, right?
Right. And we had a comment from Philippe as well. He was just sending some links in. Philippe, the floor is yours.
Yeah. So yeah, thank you for the presentation. So we happen to have built a tool, similar tool in About Code, to detect specifically AI-generated code. And two things. One, it's very clear that it's very easy to prompt a Gen AI tool to generate code that's highly similar to open source code that was used in the training set. I don't have terabytes of index on this project, but we did a simple test, which is to take the 50,000 most popular JavaScript NPMs, run them in scan code, match code, about code for indexing, and then ask ChatGPT through the API, so OpenAI really, to generate code similar to each of the 100 most popular NPMs. And it's highly unscientific, right? There's no claim that it matters, but we got strikingly similar code generated in 20 to 30% of the case. So the thing is there. Now the question is this really material? That's the jury is out, and I really don't know there. The thing is, business-wise or legal-wise, there's maybe a concern. Engineering-wise, leaving aside license issues, I really don't know what the problem or where the problem lives until there's a security issue. And security issues at the code fragment level is something that's hard to get to. Now, again, I think there's clear copying going on. It's obvious. I see the test done by you, Enrique, clearly marked that, and you're definitely a real scientist. I am not. I have anecdotal evidence using completely different technologies, that different data set, different approach that come to similar conclusion. And there's also proof points from other research in the space, be it in the code or regular kind of text. And I like to think very simply to that a model is a compressed representation of its training data set. And if it's a compressed representation of the training data set, it does eventually contains the code, in the case of code, that was used for the training. And so how is it different at a high level, conceptual level, from compressing a zip with code? Here you compress code in an LLM. It's a lossy compression. The same way, for instance, a JPEG compression may be lossy, or an MPEG compression for a video may be lossy. And I doubt that if you were to compress a copyrighted image in JPEG, somebody would say, oh, this is no longer copyrighted because you've compressed it with JPEG. So I think there's a lot of interesting arguments there. Just one last segue. I don't want to steal the floor there too much. One segue there on the topic of GPL that you raised, Marcel. There's a project done by Hugging Face called Big Code, in which they have a data set called StarCoder. Oh, no, actually, yeah, the model is called, the data set, the training data set is called the stack, which is a subset of software heritage historically that's been scanned with scan code for license to make sure they would not unduly include code, whether proprietary or copyleft, that would eventually poison the output of models built on top of the data set. So there's actually interesting work to build models responsibly in the domain. I'll yield the floor.
Right, we have several comments. Marcel saying it would be interesting to see if different open source tools or setups could be used to confirm the study results for each other to have a stable base. In other words, Marcel would appreciate collaboration between ScanOSS and About Code. Smiley face.
Oh, yeah, I'm all for that. My understanding, so what we're doing is everything we do is open code and open data. And I understand is that the data used in the case of ScanOSS are not fully open.
Philippe, we agree on cooperation, and we're coming up with an open data set that you will like a lot. And I think that the cooperation between our two open source projects, having now open data as well, will be very beneficial. to the whole community and ecosystem.
Yeah, well, that's awesome. Let's discuss. So sure.
Yeah.
Fantastic. There you have it. Proof positive that on OpenChain webinars we make strides in community engagement. Probably our closing note from a question or commenter is Mattia just saying he has wondered whether things like the GitHub Copilot option to exclude open source from generated code wasn't just making things worse because GitHub hosts open source and proprietary code. So if it was to exclude open source code, what would be the risk of it being inspired by proprietary code? Interesting question. I guess the answer to it lies deep in the technical implementations that people have. Right.
Yeah. So I'd be interesting to get really a legal opinion from somebody like Mattia and real lawyers like you, Mattia, because to me, I have no idea what are the general implications of Gen AI for code and beyond code in terms of copyright, but in the world of code and open source, is if we are eventually able to distill open source code in something new, then what does it mean for licensing and open source at large? Take a stupid, thought experiments where you build a small language model carefully from a data set that's been scanned, say, with Scan Code Toolkit, and you're sure that every bit of code you have there are GPL licensed. And now you use that for generating code. My simple mind says the code has to be derived from GPL code because that's the input. And so I really don't know. It's probably not the forum there, maybe the FSFE legal network and other places. But I really wonder what it means, because if it doesn't matter, then literally licensing doesn't matter, and open source is dead. Welcome to vibe coding, because that's the new way to actually essentially reuse open source code without restrictions.
Food for thought. It looks like this is webinar 1 of many on this topic. We're going to have to come back to it. We're just about out of time on this webinar. I have to say thank you, Oscar, for coming here and presenting. Thank you for the ScanOSS team for showing up en masse, and for our audience. It's fantastic to have Philippe here from the About Code ecosystem. It's fantastic to have people like Mattia and Marcel on the line, and I look forward to publishing our recording early next week, I think. Thank you again, Oscar. You've been fantastic.
Thank you, guys. Thank you all for attending.
Alrighty. Take care all. Have a great weekend. Bye-bye.
Bye-bye.